All right, welcome everyone. If you're an HVAC tech, you know this story all too well. A massive equipment failure that started with a tiny hidden problem. Well, today we're diving right into the heart of the machine. We're talking about the shafts and bearings that keep everything spinning. Let's jump right in.
Yeah, you know the feeling. You walk into a mechanical room and you hear it. That awful grinding, that high-pitched whining or squealing. That's not just random noise, folks. That is the machine literally screaming that something is wrong. That's your number one clue, and by the end of this, you're going to know exactly how to read it.
So, here's our game plan. We'll start with shafts, the power movers. Then we'll cover bearings, the real unsung heroes. After that, it's all about installation and alignment, followed by lubrication and proactive care. And we'll wrap it up by learning how to decode all those signs of trouble.
Okay, let's kick things off. Section 1. Shafts, the power movers. You can think of these as the rotating backbone of your HVAC equipment. It's pretty simple. Without them, nothing's moving.
So what exactly is a shaft? I mean, at its core, it's just a rotating component that transmits power and supports loads. You've seen them a million times in motors, fans, and pumps. It's that critical link between the motor that's creating the power and the fan or pump that's actually doing the work.
Now, shafts are always under pressure from two main directions. First, you've got your radial load. That's a sideways force, right? Think about the constant pull of a belt on a motor pulley. That's trying to bend the shaft. Then you've got the thrust load. This is a force that's pushing or pulling along the length of the shaft. End to end, this causes a twisting stress. A good system has to be able to handle both of these forces, day in and day out.
Okay, so that brings us to Section 2. Bearings, the unsung heroes. Seriously, if the shaft is the star player, the bearings are the crucial support team that lets them do their job. They reduce friction and support all that rotation. And look, if you remember just one thing from our whole chat today, make it this. The 3 rules of bearings. Keep them clean, keep them properly lubricated, and keep them correctly aligned. That's it. That's the Holy Trinity. You nail these 3 things, and I promise you, you'll prevent most of the failures you see in the field.
So, what are you going to find out there? Well, it usually comes down to one of these 3. You've got your classic ball bearings, they use little spheres, and they're kind of the all-rounders for radial and some thrust loads, perfect for fan motors. Then, for the heavy hitters with high radial loads, like big blowers, you'll see roller bearings. They use cylinders for more surface contact. And for the really big jobs, with intense radial and thrust loads, think huge fan drives, you'll find tapered roller bearings. Their cone shape is just brilliant for handling both forces at the same time. All right, Section 3, installation and alignment. This is so important because you have to get it right from the very start. Honestly, a bearing's lifespan can be decided the second you install it. Look, this isn't just a suggestion, this is how the pros do it. Step 1, everything has to be spotless. Clean the shaft, clean the housing, dirt is the enemy. Step 2, make sure the fit is right. And step 3, please use a bearing puller or a press. Never ever force it with a hammer. You could destroy a brand new bearing before it even starts spinning. Then, of course, install your seals to keep contaminants out. And finally, don't walk away without checking your runout and alignment. That's your final sanity check. And here's how precise we need to be. We're talking about a maximum of 5/1000ths of an inch for total indicated runout, or TIR. So, what does that even mean? It's basically a measure of how much the shaft wobbles. And 5/1000ths, that is thinner than a human hair. So if your dial indicator is reading more than that, you've got a big problem. Either a bent shaft or your alignment is way off. It's got to be fixed. Moving on to Section 4, lubrication and proactive care. And let's be clear, this is way more than just a task to check off a list. This is the absolute lifeblood of your bearings. So, your lubricant is actually a triple threat. Yeah, obviously, it reduces friction. Everyone knows that. But it's also pulling double duty by removing heat. And third, it's acting like a shield, protecting the metal from corrosion. It's doing a lot of work in there. Okay, so this leads to a huge question, and a really common mistake. Is more grease always better? I mean, you've seen it, right? A pillow block bearing just caked in grease, oozing out the sides. The thinking is, hey, can't have too much of a good thing. But is that true?
No way. In fact, over-lubrication is just as damaging as under-lubrication, sometimes even worse. Think about it. When you pack too much grease in there, the balls or rollers have to literally plow through it. That creates a ton of friction and heat. The heat then destroys the grease, and the pressure can blow out the seals. And once the seals are gone, you've opened the door for dirt and water to get in. Game over. And that brings us to our last section, number 5,
decoding signs of trouble. This is where it all comes together. We're turning you from just a technician into a full-on detective.
You know, your best tools for finding problems are the ones you carry with you every day: your ears, your hands, and your eyes. Noise is almost always the first sign, accounting for nearly half of all clues. That grinding sound is a huge red flag. Then comes temperature. If you can feel excessive heat, that's a major warning. And finally, vibration. A good running machine should be smooth. If it's shaking, something's wrong.
So how hot is too hot? Well, here's a solid number to keep in your head. Anything over 70 degrees Celsius, that's about 160 Fahrenheit. If you put your hand on a bearing housing and it's that hot, you need to investigate pronto. That kind of heat means there's some serious friction going on, maybe from overload or bad alignment.
Okay, this right here is your field guide, a quick troubleshooting chart. If you hear a loud grinding, yeah, the bearing's probably shot, but you have to check the alignment before you put a new one in, or it'll just fail again. If there's a lot of heat, your first thought should be lubrication or alignment. And if you've got vibration and noise, that's when you should really suspect a bent shaft or severe misalignment. Time to get out the indicator.
So let's recap the big stuff. Shafts transmit power, bearings support them. Simple. You've got your three main bearing types: ball, roller, and tapered roller. The three golden rules, I'm going to say it again: keep it clean, keep it lubed, and keep it aligned. Make it a habit to check for weird noises, heat, and vibration every time you're on a call. Trust me, doing this stuff right can add years to the life of the equipment.
So I'll leave you with a final thought. The next time you walk into a mechanical room for a maintenance call, what's the first thing you're going to check now? Are you going to listen a little more carefully to that fan motor? Maybe take a second to feel the bearing housing for heat. When you start paying attention to these little clues, you're not just swapping parts anymore, you're a true diagnostician. Thanks so much for joining me.